Okay, well, welcome everyone. I was asked to talk about soil health on grazed lands, and so I'm not going to talk only about rangeland. I'll be talking about kind of like here in South Dakota. If you There's very few people that are just ranchers or just farmers. They pretty much all have some farmland and some ranch land, and there's very few people that own livestock where those livestock haven't probably spent a part of their life on cropland. So I'm going to delve into grazing on cropland as well as grasslands. I'm just going to kind of, for this presentation, lump them together, but I will talk a little bit about rangeland as well specifically, and probably get more into that tomorrow on the take your soils to the doctor session. But at any rate, we'll jump right into it here, and get my pointer ready too. Okay, so some of what I want to try to talk about today is describing some of the advantages and challenges of grazing cropland and perennial grassland. Talk about some of the impacts of grazing cropland and perennial grassland, and also some of the impacts on animals. Also going to briefly mention adaptive grazing management, kind of what it is and what it isn't. And then kind of briefly again talk about some management strategies for cropland and grassland. So start off with cropland. What are some advantages of grazing cropland? You know, it goes almost without saying, but livestock manure is a good source of nutrients for crop production, basically cycling those nutrients through the animal back to the land. And so there's a couple of these bullets here have a asterisk on them that just is tying to a citation in the slide notes. So if you can, if you're able to download this presentation, there's more information in the slide notes. Also, livestock on cropland, it's kind of a biological acceleration thing where it helps to improve soil health at a faster rate and possibly to a further extent. And so livestock add biology, and I'm going to delve into that a little bit more later. But they also, that standing biomass, they help to incorporate it down into the soil surface so that gets those decomposers more ready access to it, and speeds up that organic matter being incorporated into the soil. Obviously, additional source of income from livestock on cropland, a source of income that you wouldn't normally have if you don't incorporate livestock. Increased nutrient cycling, I'm going to touch on that briefly as well. There's been some studies showing increased mycorrhizal fungi abundance on cropland where livestock are incorporated. More rapid building of soil aggregates as well, improved infiltration. And this, in our neck of the woods, we have issues with salinity on cropland. And so, but you can think of this as just poor spots. Most cropland, there's some poor soils out there. And if you think about those areas, when you do the math, you can actually, if you take those areas out of production, out of cropland production, you actually many times are going to be further ahead from an economic standpoint than trying to farm them every year, because they just aren't going to produce the yields that you want. So what do you do with those areas? You can take those areas, at least in our area here with the salinity, and plant them to perennial vegetation. So when you do incorporate cover crops onto your cropland and you're out there grazing the cropland, the cover crops, that perennial grass is a way for those animals to balance their diet, if you will, because many times livestock are coming from dry pasture or less quality of forage onto these cover crops, and that high quality forage is kind of a hit to their system, so they'll actually go backwards for a few days. And if they have perennial grasses out there, they can balance their diet and keep going on a even plane of nutrition. And so that's a benefit there. And also minimize import of feedstuffs to the farm. So if you have the ability to graze those cover crops, you're not buying as much feed, you're not overutilizing the pastures. So it's just reducing costs that way. A potential increase in diversity of insects. There's been some studies to show that, to help reduce pest species. And then from this study, they showed that livestock serve as a sink for agricultural byproducts. So if you think of these areas, especially to the east of us here, there's large areas where livestock have been extirpated, if you will, from the landscape. And so when people start bringing livestock back into these cropland areas, it really bolsters those local economies, and they start selling products and expanding their product line, and that really serves as a hit for the economy for these small communities in these areas. Also, when people start bringing livestock in, they do many times start developing perennial forages on the landscape as well, and so it encourages that, and it diversifies the landscape, that type of thing. But there's also some challenges to grazing cropland, and so I'm going to open up the chat here, and if you would just type in the chat, look at that picture there, and what do you not see in that picture, that little inset picture there? Yeah, no fences. Oh, you don't see soil too, but no fences, and so that's a big challenge in these areas that have been heavily cropped uh, for going on generations almost, is that there's no fences, and not only that, but if you take a step back, you think about the generation that's coming up into farming right now. When the livestock had been removed for quite a few years, they're coming into it, and if they want to incorporate livestock, they don't have really any knowledge or familiarity about herd health, livestock management, uh, how to build a fence, maybe, and what, that kind of thing. So there's lack of knowledge or familiarity, and just that hesitancy to try it, if it's something brand new to them. Without a doubt, there's an increased level of time and management to prepare the operation to move fence livestock. So there's a lot more, I wouldn't say a lot, but there's more work that goes into it if you're going to incorporate livestock back onto cropland. But then really there's just that lack of grazing infrastructure too. No fences, no water, or if you do have fences, they're in pretty poor condition. So that is an issue. That's a challenge. There's potential hassle of working out lease agreements with livestock owners. How do you set up an agreement like that? But that I think is pretty surmountable. You can work around that. There's potential risk of livestock not being moved frequently enough and causing compaction. But I think from the studies that I've looked at, and some of them I mentioned here, that's really usually not a problem. If you just use some common sense management, that's not going to be a big issue. Also, liability if livestock cause accident on public roads. And usually when I give this presentation, it's in a specific area or state, and so I'll look up the laws related to loose livestock and legal fences and all that. But since this is across the country, I'll just mention that almost in every state I've looked at, as far as their laws relate to this, is that the livestock owner or the landowner has to be shown to be negligent for this to be a big problem. And so as long as they're attempting to fence their livestock in and manage their livestock, usually this is not a big issue either. But there is this thing, and Bianca showed this too, this diagram. This one's just slightly different, and you have your innovators and then your early adopters, and there's when we had been doing the rainfall simulator in South Dakota for almost 10 years, we took a step back and we said, do we really want to keep doing this rainfall simulator? And so the leadership had a meeting, and they said, hey, let's get South Dakota State University to do a survey for us. So in 2014, they did a survey at every rainfall simulator event. And the results of that survey were pretty astonishing. They found out that of the people that attended those rainfall simulator events, 61% had never seen it before, and 71% made some kind of management change on their operation just from watching that rainfall simulator. So I say that to say that we're pretty good about getting people interested and even drawing in those early adopters, but there's this chasm that happens. And the way I explain that, the way it makes sense to me, is what happens, people will take on to this new technology and try it for a couple of years. And early on, many times they'll have some success, but then they hit this wall. It's like, man, everything goes wrong. And so then they're like, this doesn't work. I'm going to quit and go back to the way I did it. And many times what's happening is it takes some time for that conventionally managed soil to start changing and really becoming more, increase in soil health and becoming more of a natural ecosystem in the soil. It takes, 5 years maybe, is what I've heard, but it takes some time. And if they don't stick it out past that time frame when the soil really kicks in, then they will drop out at that point. And that's what I kind of refer to as the chasm. But anyway, that's an issue, and so they never make it to the early majority. Really, they just they just stop right there. So looking at some research on impacts on soil health. So I kind of lumped these together, but research on grazing cover crops in Minnesota and Iowa, what they showed was increased fertility, increased total organic carbon, inorganic carbon, total carbon, and increased total living microbial biomass. In Georgia, grazing cover crops did not cause substantial physical damage to the soil, and they, of course, got the benefit of having the increased income on livestock. Yes, Beth, feel free to add questions here, and I'll try to watch the chat as we're going. Also, research on grazing crop residues. In Iowa, utilizing corn stover was an inexpensive feed source and a viable option, posing minimal reductions to soybean yield. Nebraska, this study is a long-term one. It's gone on for 20 years, I think now. And what they found is that long-term grazing corn residue had little to no effect on soil properties and did not affect crop yields. So it can be done if it's some common sense is used in managing it. This is not a peer-reviewed study here, but this was a point-in-time sampling of the soils. And this is on Gabe Brown's ranch up in North Dakota. And I believe Rick Haney did the sampling, but this was on-farm field testing. What they did is they did sampling on Gabe Brown's place, and then they went across the fence on similar soils and did the same tests. And Gabe Brown, he has cover crops, very diverse crop rotation. He incorporates livestock, and he has no-till. And most of the neighbors don't have any of those components. They're conventional farming, conventional tillage, no cover crops, pretty simple crop rotations, and no livestock. What they found, you can read the list there, but 7 times higher nitrogen, 4 times higher phosphorus, and on down the list, 4 times higher organic matter. But look at that one on the bottom, 43 times higher infiltration. And you're probably like, no way, that's just not possible. But I've worked with a lot of dynamic soil property studies, and I will say that is probably true. You can have a huge impact on infiltration when you manage the soils properly and you improve that soil health. So that's pretty amazing, but I believe that's right on the money. Okay, so moving to grasslands. Research on grasslands in Texas, and what they did is they compared heavy or light continuous grazing to multi-paddock grazing, basically rotational grazing. What they found was on the rotational grazing, they had greater soil cover, lower soil penetration resistance, so probably lower bulk density, lower sediment loss, higher organic matter and cation exchange capacity, and increased mycorrhizal fungi. This was an on-farm trial in Mississippi comparing high stock density rotational grazing to continuous grazing. What they found with the high stock density rotational grazing was several times higher total soil carbon in the topsoil and subsoil, and significantly greater soil organic matter in the topsoil and subsoil. So what are some advantages from grazing grasslands for soil health? Now think about, I'm going to kind of talk more about rangeland here in this instance, but rangeland compared to pasture, compared to cover crops, the quantity may not be much different on rangeland if it's healthy and producing well, but the quality is a big issue. When you deal with a very diverse plant community, you have plants that are greening up and maturing at different times all throughout the growing season. And so that really widens that window of palatability for livestock. They're constantly having different species that are at a higher palatability level, a higher forage quality level. So that really helps with the nutritional level of the animals. But also grazing that provides for adequate leaf area is going to protect the soil from raindrop impact. It's going to reduce evaporation, increase infiltration, and improve plant vigor. And so as you do that, and you manage for that, you're going to maintain or improve plant diversity, which for me out of all the soil health principles that Bianca mentioned, I think maximizing diversity is probably the most important soil health principle on grassland. I think you can do more for soil health with that principle than probably all the others. So what are some other advantages for grazing grasslands for soil health? Less need for mechanical harvests. Make those animals earn their keep. They're good. They're basically a harvest machine. Biological acceleration. I mentioned this earlier. There's been quite a bit of work connecting the rumen of livestock with the ecosystem, the biology in the soil. And what they found is a pretty strong connection between the manure and urine and saliva, and possibly even a connection with milk foam, where that biology is really, directly adding biology to the soil. In fact, there's one study with goats where they were able to isolate and find fungi species that were living in the rumen of the goat, and the same species living in the soil. And then some other studies with cattle where they found a connection between the methantropic bacteria and the stock density of cattle. So there's a real connection, I think, between the rumen and the soil biology. And then basically, like I mentioned earlier, incorporating that organic matter. So you got that standing residual or biomass. If you incorporate that down to the soil, then you get a much faster decomposition and contact with those decomposers. And increased nutrient cycling. I'm going to mention that just briefly here too. And improved animal health. The more time animals can be out there grazing versus being in confinement, they're typically going to have better health overall. So this was I think this was actually a CIG project initially called the Pasture Project. If you look in the lower right-hand corner, there's this Pasture Project. You can look that up online, and they have a lot of information. But I believe it came out of Minnesota. But what they found was, looking on the left there with continuous grazing, moving to the middle to a 4-paddock system and then a 20-paddock system. And one thing I want you to focus on is that little pie chart or thing that looks like a clock there. And when you think about continuous grazing, it's pretty much for the growing season anyway, it's 100% of the time grazing. If you move to just a 4-paddock system, then you have basically 75% rest and 25% grazing, a huge difference. And then take that on to a 20-paddock system, you just have a sliver of time when there's grazing, and most of the time is rest or deferment. So I had my predecessor that was here before me in South Dakota, he said that first cross fence is the biggest bang for your buck. You change from 100% time of the time grazing to 50%, and you'll start to see impact. So, I recommend to people to start small. Don't design a 43-paddock system right off the bat, but just get them used to the idea of and they'll start seeing changes as they just start rotating and doing that kind of stuff. But some other things you'll notice here as you move from a continuous grazing to 4-paddock system, look at the how deep the water is infiltrating here. You also see increased, with the width of these arrows, increased microbial activity and increased stocking density. But then look at the diversity of the microbial community here and the depth of the water infiltration. That's some things they found with this study on the Pasture Project. Pretty neat deal. All right, so this is a principle that you may say, well, now I'm going way back if you recognize this. But this came from a study in 1955, Franklin Kreider. And what he did is he took a number of species of grasses and he removed biomass at different levels above ground, and he one of the species was smooth brome, but there were several different species of grasses involved. And so the percent removal on the left there, that's percent by weight. So when you take 10% by weight of the leaf area of the leaves above ground, you have 0% impact on roots. There's no impact at all. Take off 20% by weight, again, no impact on roots. 30% by weight, 0 impact. 40%, nothing. When you get to 50%, you hit this level where 2 to 4% of the roots stop growing. Okay, not a big deal, but there is a little impact. But look what happens when you get to 60% removal by weight above ground. That jumps to 50% of the roots stop growing. So just basically, if you were able to count the roots, half of them stopped growing at that level of removal. 70%, 78% of the roots stop growing. When you get to 80% removal, 100%. Now that you think that makes sense, but not only was there half, at 60%, half the roots stopped growing, but the length of time that they stopped growing for was longer with each level. So like at 60% removal, half of the roots stopped growing for 2 to 3 days. At 70% removal, 78% of the roots stopped growing, and it was pushing out to a week. And when you get down to 90% removal above ground, 100% of the roots stop growing for, I think, almost a month. And when you read the study, you see that it's not only how many roots stop growing, but the length of time they stop growing for. Anybody in the chat, what principle do we talk about sometimes that came from this landmark study of 1955, which, by the way, people have tried to refute over the years, and it still has proven to be true. Anybody know the principle I'm talking about? I'll wait for the chat here. I'll take a drink of coffee while I'm waiting. Maximize living roots. Okay, that's kind of related to that, yeah. Reduce disturbance. Okay, there's a principle in grazing management we call leave the leaves. I'll talk about that too. It's called take half, leave half. That's a principle we've used in grazing. And actually, there's been some people saying, oh, that's not really valid anymore. We can manage. Yeah, you can manage at a higher intensity level, but you still are going to impact those roots. The fact that those roots are impacted is a principle that has really stood the test of time. So take half, leave half. Yes, there you go. That's the one I was looking for. All right. Now, focus here on the left over here on the tall fescue. This is the amount of leaf area that was left for these plants. And look at the leaf area that was removed on these. And then look at the root mass here. Nice, healthy, thick root mass here. Oops, what happened to the roots over here? So, yeah, I mean, it's just showing that principle again. Again, this is from a great publication I really recommend. It's called Grass, the Stockman's Crop. And it's probably one of the best publications if you just wanted to hand a publication to a producer, a rancher, pastorist, whatever. This one is in pretty plain language, and the principles are really sound. And so on the left, what it's showing over here is this is just a good, healthy grass plant with, nice full root system. This picture in the middle, what it's kind of depicting here, what it's talking about is that each and every year, perennial grasses are going to lose from 30 to 50% of their roots. And that's just the natural system. So think about that. 30 to 50% of the roots die off, slough off, or eaten, whatever. But each and every year, they lose 30 to 50% of their root system. The more recent research has shown that that's really probably closer to 50%. Thanks, Beth, for sharing that. Yeah. So think about that. Half of the root system just disappears every year, and they have to replenish it every year. So if take this principle with the one previously, if you're diminishing that, if you're stopping root growth during their growing season, you're going to slow down that replenishment period. And if you come back and regraze those pastures more than once each time, and you're grazing it at a level that's lower than that 50%, you're going to be hitting that grass. And eventually what happens over time is you'll start seeing that root mass shrink. And then, of course, then you leave it open for weed species to come in and compete. So I might have to come back and catch some of those chat comments. But yeah, so that's okay, Amy. And I'll probably talk about that a little bit more. As long as if you remove short duration doesn't necessarily mean taking more than half. In fact, a lot of the short duration systems I've seen, they actually only take about 30% of the leaf area on top. But you can take more than that half if you leave adequate time for recovery. That's the key point. but do just keep in mind that it does impact the roots, at least for a period of time. All right, so let's talk about leaves now. We're going to kind of stack all these principles together and try to keep that in mind when you're managing, designing a grazing system. So this is what I call leaves, the facts of growth. So it's true, roots do uptake and send water and minerals and micronutrients to the leaves. So the roots are grabbing that good stuff, the water, the nitrogen, the potassium, and all that good stuff, and they're sending that up to the plant above ground. That part is true. However, roots do not transport the more complex, the non-structural carbohydrates that are being transported down there. They don't transport those back up to the plant above ground because those molecules are just too big and heavy to make that trip. All right, but it's also true the above ground plant, the leaves, they need those carbohydrates to respire. You know, all living things respire. They need energy to do that, and they need to get it from somewhere. Where does it come from? So what they found is, this is in perennial grasses, 5 to 10% of new leaf growth, and that's either after a grazing event or in, you know, spring growth, when growth initiates in the spring. 5 to 10% of new leaf growth is from the residual sheath. And if you think of a grass plant, there's that sheath kind of at the base that wraps around the stem. The upper part of the crown, and also from the nodes, grass nodes. Recently, they have found that there's a carbohydrate storage area in the node of a grass. So if you run your finger up and down a grass stem, there's that bulgy part. That grass node, there's a small carbohydrate storage area. But only 5 to 10% of new leaf growth comes from stored carbohydrates. Where does the rest of it come from? 90 to 95% of new leaf growth comes from carbohydrates resulting from current photosynthesis. All right, that's big. That means that for that grass plant to keep growing, it needs to start cranking out the carbohydrates with current photosynthesis. So the bottom line is, it takes leaves to make leaves. Having leaving leaf area out there is critical to plant recovery and keeping those pastures healthy. Here's another principle to keep in mind, and this kind of relates a little bit to your comment, Amy. Sorry, but take a look at this graph. This is one of my. You could spend all day just talking about this graph, but what it's saying is, on the bottom is the cattle stocking rate. So this is from 0 to just increasing the stocking rate, or you could say the herbage or forage removal rate. So that's increasing stocking rate going out this way. This is the amount of soil organic carbon that's being added to the soil, increasing this way. So at 0, you've got a level here, whatever those units are, I don't know, but the level is about 39. As you increase stocking rate, the level of soil organic carbon that's added increases with increasing stocking rate to a point. But what they found is, when you keep increasing that stocking rate higher and higher, you start diminishing the amount of soil carbon that's added to the soil. And then way over here is hayed ground. You know, annual haying is kind of the worst of the worst, and we'll talk about that more in a minute. But that principle is really, really key and really important. Yeah, law of diminishing returns. This graph shows up in so many things in nature. It's kind of funny. All right, so this is a rainfall simulator. This is one I did on rangeland, and I had, basically, if you haven't seen this before, the rainfall simulator is essentially the same soil in every pan here, just different management. This is different kinds of management across here. And what you do is you turn the rain on, the sprinkler, it rains, you add 1.5 inches to 2 inches of water. Any water that runs out this funnel in the front is your runoff, and that's bad. You don't want that. And that goes in the jar in front. The water that infiltrates through and drops down goes into the jar and back, and it's good. That's what we want to see. So when I did this rainfall simulator, what I was going for was the cell phone bars kind of effect. So if you look at the infiltration jars, I wanted to start low and keep increasing as I went up to the right. And then the opposite on the jar in the front. So it worked pretty good. You know, I had a prairie dog town. We have prairie dogs in South Dakota. This was an overgrazed blue grama buffalo grass sod. This one in the middle was Kentucky bluegrass, and I'll talk about that more in a second. This was a totally rested for many, many years, ungrazed smooth brome. And then this was a well-managed, diverse rangeland pasture and range. Now, what happened was, at the time when I did this, I thought plant community was the driving factor for infiltration. I thought it's all about plant community. And Kentucky bluegrass, if you know anything about it, it's not typically good for infiltration. But what I found out through doing this rainfall simulator was management. The management really can override plant community, but is equally as important as plant community. These two samples right here, this one and this one, were taken out of the same paddock, the same management, only about 20 feet away from each other. This was Kentucky bluegrass dominated. This had big blue stem, Indian grass, western wheatgrass. And so they both infiltrated about the same amount, very little runoff, and it really kind of shocked me. But another thing that's shocking is, look at this smooth brome. Look at that. It's the tallest of the grasses right here. Management is so important. This has been ungrazed for 50 years plus. It's a section line road, no grazing at all. There's more infiltration, but look how much runoff it got. It's about half and half infiltration to runoff, roughly. And so you'd think this would have great infiltration, but it's not as good as it should be or could be if it was managed better and had a better plant community. So, all right. This is just a very simple depiction of the carbon cycle. And you think about the carbon cycle, you've got your plants, they respire, they give off carbon dioxide. You have some soil organic matter as the plants decompose, slowly decompose, they add soil organic matter, that gives off carbon dioxide. This is a simple system now without livestock, but look what happens when you add livestock. It just makes that system much more robust and much more complex. The plants are eaten by the livestock. They poop it out on the ground. You get manure adding, pretty rapidly to that soil organic matter. The livestock are respiring, giving off carbon dioxide. As I mentioned earlier, the rumen microorganisms are interacting with the soil through the poop and urine and saliva. And then, they're giving off methane here. There's photochemical oxidation, converting it to carbon dioxide. So just a much more complex, robust system when you add livestock to it. And it's very similar for the nitrogen cycle, but I don't have time to get into that right now. So, all right, this is another principle that's pretty important with grazing management. And you may have seen this before. This comes from Jim Garish is kind of the source of this. But what it's showing is that the length of the grazing period can have an impact on livestock performance. And so daily intake is known to be directly proportional to livestock gain. So the more they intake, the more gain they're going to have. And when you look at this is as a percent of their body weight here. And so the longer you're in that paddock, look what happens. So on day one, basically 4% of their body weight is being intake and by the animal. On day two, it drops down to maybe that's 3.75. Day three looks like a little below 3.5%. Day four, it's dropped down to 2 point something. So as you can see, intake drops off in these animals the longer they're in a paddock. Day 7, it came up a little bit, but that probably was not significantly different than that one. So why is that? Anybody want to hazard a guess in the chat? Why is it that their intake diminishes the longer they're in a paddock? And this, my next slide will kind of talk about that, but any thoughts?
When you say intake, you mean the amount of food they're eating?
Yeah.
So there's just less of it, maybe?
Yeah. Okay. I think, sorry, Theron. Yep, Nicole, you're getting it. They're eating the most desirable forage first. And as time goes on and that gets removed, they're having to go after something that's not so good. And then they keep in mind, the lower the forage quality, the slower it passes through the rumen, and that inhibits their intake, how much they can eat. So that's just how it works. And so here is just showing, this is if you take 50% by weight. Now keep in mind, 50% by weight is not 50% by height. So 50% by weight is usually a little lower than the 50% by height line because there's more weight in the bottom. But look at this forage quality. In the top half by weight, the crude protein is 14%, TDN is 63.5% relative feed value. I don't pay much attention to that number, but the crude protein and energy, 14%, 63.5. Now look at the lower half of that plant. Crude protein, 7.2%. TDN, total digestible nutrients, 56.3%. Now, when I do some math, and if you look at what they call the DOM, or digestible organic matter, to crude protein ratio, you can actually determine if an animal is going to gain weight or lose weight. And if the ratio is between 4 and 8, an animal will typically gain weight. They'll be okay. When I did the math on this lower half, it came out above 8. So basically animals in that same stand of forage, if they're eating the lower half, they're going to lose weight. If they're eating the upper half, they're going to keep gaining weight. So pretty interesting stuff. All right, so grazing system objectives. Keep in mind, grazing is just a tool. Yeah, it's pretty much true regardless of the livestock. The question was, is it true across differing livestock? Yeah, it's just a forage. It's just a forage thing. The higher quality stuff is a forage quality. If you do a forage quality test, the higher quality is going to be up higher than the lower half of the plant is usually going to be lower quality. So, so grazing is a tool. That's all it is. You can improve the resource or you can degrade the resource. And Bianca touched on this a little bit too. So to make sure you're improving the resource, and keep in mind, it's like that stock the stockman's crop. Sorry, the grass is really what we're managing, not the animals. The animals are just your harvesting machine. Of course, you got to manage animals too, but they're your harvester. So, but when you're setting up a grazing system, one objective is you got to provide adequate nutrition. The animals they're working for a living. You got to provide, so you need a feed, forage, animal balance. Make sure the animals are getting enough food. That's number one. But number two, you go right into protecting and feeding the soil, feeding that above ground herd and the below ground herd, like Bianca mentioned. And then thirdly, you got to work within the manager's labor and their social constraints. Like I mentioned earlier, you could design a nice 43 paddock system. And if that person has a job in town, when are they, it's going to be very hard for them to move livestock every day, or whatever. So you got to keep all that stuff in mind. But by and large, in incorporating livestock and using livestock, it's going to be a fast track to soil health. You want to mimic nature as closely as possible. All right, so looking at natural disturbances, they stimulate major ecological change. You think about tornadoes, hurricanes, earthquakes, volcanoes, lightning strikes, wildfires, insects. All these things may not have a direct impact on grasslands or grassland management, but they're just examples of acute disturbances that can stimulate major ecological change. And don't gloss over the insects one. That can be huge. And so all these can have an impact on the ecological system. When it comes to dimensions of disturbance, let's think about that for a minute. It's timing, frequency, and intensity. And disturbance patterns that stimulate major ecological change generally exhibit variable timing, low frequency, and high intensity. And let's touch on that a little bit more when it comes to grazing. So we're talking about acute disturbances here. And in relation to grazing, the timing is typically variable. They don't happen at the same time every week or every year. It's different times of the year, and they're very variable. Frequency is usually low. And when you think about frequency of plants being grazed, think of an individual grass plant. How many times is that individual grass plant being grazed off? How many times per day or per week or per month? That's kind of what we're talking about here, that frequency. How often is it being grazed? And then intensity is typically high. We're talking more about stock density here. But the plants are grazed light to moderately, and that enhances the root biomass. There's a high degree of trampling that adds that surface cover or soil cover and feeds soil life. And usually short duration grazing. Depends on the growth rate, resource concerns, that. That's to prevent regrazing of those desirable plants. We want to minimize that. Compared to chronic disturbances, which in other words, otherwise known as continuous season-long or continuous seasonal grazing. These are the kind of biological disturbances that typically result in poor soil health. I say typically because there's exceptions, but normally it's not a good thing. So, but the characteristics of that, the timing is unchanging. They're grazed at the same time of year every year. The plants are grazed frequently. That individual plant gets grazed off every time it sticks its head up there because it's the nicest quality thing. The livestock are nipping it right off again. And intensity is typically low, very few livestock out there per acre, but they're grazing everything usually pretty short, and there's long graze periods. Now, there's one advantage to continuous season-long grazing. It doesn't require much skill. So that's pretty big, advantage, but your outputs, your outcomes are not going to be very good either. So think about this diagram here. Your livestock in a continuous grazing, your livestock are going to stay closer to the water. These little brown manure patties, they're going to be highly concentrated over here. The urine, the little X's, that's your urine spots, they're going to be concentrated over here. The grazing is going to be much heavier over here, very, very light to no grazing over here, and your nutrients aren't distributed very well. That's a typical continuous grazing kind of distribution pattern. But up here in our neck of the woods, we also have what we call patch grazing. And so patch grazing is another thing you see with continuous season-long grazing. But essentially what you're seeing is overgrazing right here and no grazing right here, just 5 or 6 feet away. And that pattern repeats itself across the pasture. No grazing, overgrazing, right next to each other. So that's what we call patch grazing, which is another thing you'll see with continuous grazing. All right, shifting gears just a little bit. You've probably heard a lot about adaptive grazing or adaptive grazing management. It's just another one of those terms in my mind that kind of, the real meaning in my mind of adaptive grazing is that you're basically using feedback from the system to adapt your management to fit that ecosystem. It has to be flexible because you can be constantly changing your initial plan and adapting to that system as it's giving you feedback. It is not a specific grazing system. It can be any number of kind of grazing systems. It's really the key part of this is that adaptive. You're adapting to the circumstances and the feedback from the system. But it does realize benefit of hands-on management. Livestock are comfortable with humans, which leads to better herd health, they've shown. The power of observance. If you're out there watching that system, you're learning things as you go. And that's always a positive thing. And then minimizing risk associated with unforeseen changes. So as you look at this system, this is similar to our 9 steps of planning we have, but it's much shorter. So you plan like this thing, you assume you're wrong, you implement the plan, you monitor, you put in some controls, and then you replan. That's kind of this feedback loop it's very characteristic of a adaptive management. All right, so let's talk about, these are kind of my principles for grazing management strategies for soil health. Again, you got to start with that feed, forage, animal balance. You got to make sure they have sufficient quantity and quality of forage. That's important. But as you do that balance, then look at 3 things are key in my mind. Reducing selectivity, which goes to stocking rate. Make sure that the stocking rate is at the right level so you're getting the right utilization levels. And again, not impacting those roots overly, depending on how fast you're rotating through. Adequate recovery, that's critical. You got to have an adequate recovery period for plant health. And then changing season of use from year to year. If you think about a system like where we're at here with cool season and warm season plants, if you graze it at the same time every year, let's say the spring, what's going to happen to those cool season plants, especially the desirable ones? They're going to start to go out of the system if they're grazed every year, same time of year. So changing season of use is really important too throughout your pasture system. And remember, it takes leaves to make leaves. So some grazing planning resources. This is really kind of going more to the range side, but they're available really for range pasture or cropland. Is ecological site descriptions. There's a huge amount of information in these ecological site descriptions, and they're getting better all the time. You may not have them where you're at right now, but they're coming to your town soon. So they'll be there, and there's really good information in them. So that you can find information on those through what's called EDIT, the Ecosystem Dynamics Interpretive Tool, or you can look on the Field Office Tech Guide through USDA NRCS, and there should be they should start populating information on ecological site descriptions. With that, there's an ecological site reference sheet, and I'll talk about that probably more tomorrow when we take our soils to the doctor. But and this range health assessment, that's really important too. Also, NRCS has what they call a National Range and Pasture Handbook, which throughout my career has just been a wealth of information. There's a lot of good information in there about grazing systems, all this stuff that I'm talking about with soil health and hydrology and all kinds of good stuff. So those are some really good resources if you're doing some grazing planning. Let's look at this picture here, and I'm going to hit on this picture again tomorrow, but this is a kind of a typical scenario. On the left-hand side, it'd be my left, probably your left too, okay, is an overgrazed, continuous season-long pasture. On the right-hand side is a rotationally grazed, moderately stocked, very diverse plant community, big blue stem, Indian grass, green needle grass, porcupine grass, just all kinds of grasses, very few invasive species. Which side of the fence is going to be more sustainable, let's say more resilient, like through a drought? Oh, thank you, Beth. Basically, which one's going to have greater growth potential, if you have sufficient recovery? It's pretty obvious. I mean, this one on the left, the grass never gets much taller than that, and the grasses that are dominated over there are Kentucky bluegrass and quackgrass, and that's about it. So, through management, you can get to one side or the other. I just want to touch on haying. It's another disturbance. Annual haying. What's the problem with annual haying? You want to type that into the chat. Why do we have issues with annual haying? And think about that graph where I showed the carbon. I'm probably going overtime. Am I going overtime? Yeah, I mean, you remove all the organic matter all the time. So, all right. Compaction of soil, yeah. Okay, so here's just a dynamic soil property study site. If you look at the effect of haying on aggregate stability, yeah, and the timing too. We break for lunch at 2:30. Okay, all right. Got a little more time. Look at this picture here. So what we did is we sampled the same soil across the fence line, and so on the right-hand side was had been long-term hayland. On the left-hand side was rotationally grazed, very diverse native plant community. Look at the soil profiles there. You can see on the left, the dark colors signifying more organic matter go down much further in the profile. Excuse me. And then here, the very much lighter colors, so a lot less organic matter. What you can't see in this picture is the structure. The structure of this surface soil here was granular, very nice soil, very crumbly. Over here, it was blocky and platy. And then this depicts the fence line. But look at the aggregate stability. On the hayland on the right, the surface aggregate stability, only 20% stable aggregates. And as you go down in the soil profile, maybe coming up to 40% stable aggregates. But on the rotationally grazed, diverse grassland over here, the aggregate stability was 80% at the surface, and maybe drops down to 75 as you go down the profile. Huge difference, and aggregate stability is so important. This is that same site looking at infiltration. Now this is, tomorrow I'm gonna flip the units around here, but this is inches per hour. So what we do is we take a 6-inch infiltration ring, we put an inch on to pre-wet the soil, and then we put a second inch on and we time how long it takes for that water to soak in. So this infiltration rate on this native, high diverse, well-managed rangeland on the left, 27 inches per hour. That means basically it took 2 minutes for that second inch to soak in. The hayland, it was a 1/2 inch per hour. It took almost 2 hours for that second inch to soak in on the hayland. Remember I mentioned on Gabe Brown's place, 43 times higher infiltration rate. When you do the math, if you calculate how many seconds it is here, it's exponentially different. It's amazing. infiltration is a really good indicator of soil health. All right, just talk a little bit about management strategies. Here's kind of a real typical scenario that happens quite often. Hopefully not a lot, but it does happen quite a bit. A person will be handed a grazing plan, and it's basically by the calendar. So, you know, it's 2024. They go out, they start in pasture 1 or paddock 1. They move to paddock 2 on, you know, whatever date, and they're moving pretty much by the date, you know, and it's the same sequence of pastures. They just move around, you know, and they follow the calendar. Again, remember I mentioned changing season of use. So that's maybe not the best scenario. Let's look at a different approach. So this is rotation based on pasture readiness, if you will, or, you know, pasture production. And so here they started in paddock 2, they went to paddock 1, then they jumped to paddock 3, then they jumped over to paddock 5, then they went back to 4, down to 7, up to 6, over to 8, down to 11. So why did they make those moves like that? Well, there's one tool you can use. There's probably a lot of tools. This also came from Jim Garish. I thought it was pretty cool. It's called the grazing wedge. And I know a rancher here in South Dakota that uses this system, and it works really well for him. He's got about, I think, 30 some paddocks. And what he does is he goes out every week, once a week, and he walks through his paddocks with the grazing stick and gets an estimate of the production in each paddock. Then he takes that data back to the house and sticks it in an Excel spreadsheet, and he sorts them by production. And that's what you see here is paddock 2, 1, 3, 5, 4, and their production values going here. So then he's got a line here. This line is, if it gets down to that line, he's moving them out of there. He won't graze it past that red line. But then he also puts in another red line. And this is, if it gets up to that line or above, he's going to set those paddocks aside and use them for stockpile forage, or he might do a quick, you know, high level haying operation just to, because what happens, as we saw with vegetation that gets older, it starts losing quality and getting more rank. How did he select the values? It's a good question. I think what he used actually for this high level value was the level off the ecological site description. So in that ecological site description, it's going to tell you a production value, kind of the potential. And I think he kind of honed in on that production level. And when it started getting above that, he's like, I'm not going to graze them. It's getting too rank. And I can use that as stockpile forage better. It'd be a better use for that. So that's his boundary. And then he grazes between the lines, basically. It's a pretty cool system. It works for him pretty good. Okay, so this is kind of set up for cropland, but can be used on grassland as well. And this is called strip grazing. A lot of you have seen this, but essentially what you do is you have basically permanent or semi-permanent electric fence on the sides of this paddock. And then you have a water source here with a portable water that has connectors along this water line. Then what you do is you put out just some portable fence here and another strand here. So if these are just day-long moves, on day 1, the livestock are here. Day 2, you move that forward fence out and you take this fence out, move that one up here, and then you leave it open. And so the livestock can go back and get their water and they get a new patch of green to graze on. Day 3, same thing, but you leave the back fence open. Now day 4, somewhere between day 4 and day 7, you cut off that back fence. So then you move the water up, you put a back fence in, and then you start the whole thing over again. Anecdotally, what they say is between 3 and 7 days is what you want to shoot for. And then if you're grazing twice, though, you probably want to only do it for 3 days in each shot. Wintertime, you still want to rotate. You know, even if you're just grazing crop residue, you still want to rotate the animals, but obviously not this intensively. You can simplify the rotation much more in the wintertime. But that's kind of what we call strip grazing that works really good for grazing cover crops. Another tip, another thing that works really well is think back to that hayland. Remember, the problem with hayland is we're removing all of the organic matter and taking it somewhere else. That's the big issue with hayland. So how can you overcome that? Bale grazing is one way you can overcome that. And that's essentially you harvest the hay and then you graze it right back on that hayland where it was harvested. So you're keeping that organic matter on the land. It can also be used like on the right, they're treating some degraded areas in their pastures or rangeland with bale grazing. That's another way you can use this. You're adding organic matter and kind of treating those areas. So bale grazing is really kind of taken off, and it's a very good strategy. Some things here to manage some of this kind of temporary stuff, portable fencing and portable water. Obviously polywire, this attachment that they put on a four-wheeler to stick the polywire on. This is called a bat latch here. So if you can't be there to move the livestock, what it does is you set the timer on this thing, and at a certain time on a certain day, it just pops open and sets off an alarm, and then the livestock hear that and they know the gate's open, I can move to the next paddock. Then you come back whenever you can and reset it for the next move. That kind of stuff. Portable tanks, these above ground pipeline here with a quick couplers, so you just move the tank and plug it in and you're ready to go for the next move. That kind of stuff can really help with this kind of thing. Thinking about cover crops, just some things to keep in mind. So mixtures typically provide considerably higher production and quality versus single species plantings. So they get, again, just like that native grassland, there's a higher window of palatability when you have different species in there. Same thing with the cover crops. And, there's been some data showing better production when you have a mixture versus just a single species. So grass dominated mixes are usually more desirable for grazing purposes. That just keeps the livestock room in better condition. Warm season mixes, they're going to be lower in quality but higher yielding, higher production. Cool season mixes are going to be higher in quality but lower yielding. So just keep that in mind when you're designing your mixes there for if you're going to graze them. Herbicides, you just got to read the label. There are some pretty significant restrictions on grazing after certain herbicides, especially I think with soybeans. So just be sure and read the label. I'm not going to go into it any more than that. And this issue of forage quality issues, avoiding these issues, it's not necessarily bloat. There's a number of different issues going on here, but the principles are kind of the same. Don't introduce hungry animals into a field with super high quality. They'll just gorge themselves. So introduce them slowly, or restrict access over a 7 to 10 day period, and provide dry matter, hay, lower quality hay, millet hulls, or dry pasture, just to kind of ease them into that high quality forage. All right, so kind of in closing here, and Bianca touched on this. I'm on a campaign to change the soil health principles, at least for grasslands. And so for me, it should say optimize disturbance, optimize soil cover, but I stick with maximize biodiversity and maximize living roots. And the reason I say that is these grasslands really, they were adapted over eons with grazing, and they actually, non-grazing on a grassland is a disturbance, a negative disturbance. And so we need that stimulation and that grazing to keep these grasses healthy. Cover in our neck of the woods, you can have too much cover, especially when you get these non-native invasive cool season grasses like Kentucky bluegrass and smooth brome. You'd be amazed how much that cover will build up, that litter builds up, and then you just stagnate the plant community. So you have to manage the cover at the right amounts when you're on a grassland. And those reference sheets I mentioned, those ecological reference sheets, will tell you what level of cover that should be on that ecological site. So